So what we'll do now, we'll create the HDA two-bone IK. So for example, IK which will start from here to here, and then we're gonna reuse that HDA to create another IK from here to here. And those two IKs are necessary to create a nice reverse foot. Let's start with creating a rig vope. Here you go. And let's quickly prototype the the hardcode names, and then we're gonna create a nice HDA. Okay, so we'll jump into our rig vope and let's start with getting transforms. So we need those two joints. So we'll use our tutorial get point transform, the safe one, and we'll use the green color. And it's not gonna be a it's not gonna be the root. We're gonna use the ankle and ankle GNT, and the next one which we're gonna use, it's going to be toe, because that bone is called toe. So we can just call this one root, and this one we can call end. Let's call it L toe GNT. Cool. And let's create our empty arrays. Actually, what we can do, we can just jump to this network and copy those 4 nodes. Copy paste them here. Perfect. We're just gonna disconnect it here. So you have an empty transform array. You've seen that before. The xform goes here, and the ID goes there, and we just copy paste it, and this is going to array input. The xform goes to the value, Control C, Control V, the output of a new array to this new append, and the point number goes to the value. Whoops, not from this joint, from this joint. Cool, so that was pretty quick. Now what we need to do, we need to bring IK control, and that IK control, it's going to be from the second input. It's gonna be this one which we created here. It's actually gonna be this one here, and the name of it is whoopsie, there you go. The name of it is not the GNT. Need to select it. That's not an ankle, it's a ball IK control. So you probably remember here, yeah, it's a ball IK control. Cool. So let's dive back. Let's copy paste, switch the input to the second one, because our controls will come from a second input, which we should definitely connect it, and dive back. And here we'll call it L ball IK CTRL, and let's do IK CTRL, and let's change the color to a pink one, and joint add just to test it and see if it's okay. And we goes up, activate the, just display it, activate the Python state, and yep, looks like that's where it should be. Another one, yes, because that's where that toe is, the end. And the xform, let's see. Cool, yep, that's all good. Disconnect it, disable it, don't forget about it, and save it. Fantastic. So now let's set up our IK solver. So solve IK solver, and the signature will do target transform and the target twist, not the IDs, but the matrices. Fantastic. And we'll choose the simple solver for 2 or 3 joints, which is faster and simpler. And for now, we'll just change the lookat axis as we want to. And that's it. Let's connect things and let's see how it works. Cool. So our targets, it's our array, and let's set up a set transform, set point transforms, so we'll get the output straight away, not the points, whoopsie, the x form, no, x forms, and the points from our array, just to be sure. Fantastic. And something starts looking pretty wrong so far, and because we don't have any targets. So our root obviously is the end joint, and we'll take it and we put it here. Yes, sorry, no, it's not an end joint, it's an ankle. So this is where our root transform is. That's from here, from ankle, because we want to rotate an ankle here, and we're going to root. Our goal is our IK control. Our root is the ankle, our target is what it is, and the twist, we'll set it up in a second. I just want to show you how it works. Okay, so there isn't twist right now. Let's go up. Let's display our rig visualize. Yes, and you can see a problem straight away. So when we enable our arcade for this joint, you can see that flip happens. Yes, it's because the twist isn't set it up. So the twist is like a transform somewhere, right? Where our secondary, up axis will be looking at that transform. So ideal will be to take our ankle joint, right, as it is, and from previous. So the thing is, just to clarify, the reason why we're having one IK after another is that first what we do, we solve the leg IK, so the position of the ankle with the IK. So we just solve that part of the leg. Then output from there becomes a driver for the next IK, for this lower part of the feet. Yeah. So now we can take that ankle joint, whatever it's gonna be, and we can offset it in a z-axis, for example, by 1, and we can use that as a twist value. So we'll be sure that it will be always facing the foot position. Okay, let me just dive back, and for example, if you just take your root, which was the ankle, and you plug it into a twist, that do not solve the problem, because we said that the twist is the y-axis and it's trying to kind of match it with it by can. So let's just basically undo this. And you know what, for this one we will choose not the y-axis, but we're gonna choose the z-axis as a secondary, because we want to keep our because the foot primary motion will be here, the toes will be, bending and everything in this, and not that much in this direction. So it's better to have your vectors for your twist on that side. Okay, so you see we have a Z and it's completely twisted, right? Cool. So the easy way to solve it, we're gonna offset the transform, as I said. So we create offset transform node. And what does it do is just offsetting by another matrix, existing matrix. So we're taking our, probably that would be better to show it this way. So we're taking our root, which is an ankle, we plug it as a transform, and as an offset, we're gonna choose Z, and we can type 0.1, don't need to be super fancy. And let's bring our adjoint so you can see where it is. And you will see it's here. So that's gonna be our twist, a twist joint. So we can just hide it for a second. We don't need it here. And the out transform from here, we're just gonna plug it to a twist. And now, lo and behold, it's set it up. And that's almost there. Almost there. There's one slightly important thing which we need to do. And let's go back here. And let's get back and let's test it first. So we'll go to our repos. We're gonna clear everything. And now, if we grab our hill control, you can see now when I'm like going down, you can see, so previously when we've been going down, you see that was just the previous leg solving, right? We just solved the leg IK. We just solved the leg, but we didn't solve the foot. And now we are solving the ankle rotation here. So now you gonna have a nice reverse foot. And then what's gonna happen? We will basically go and create some extra attributes for our joints here to rotate, and you're gonna be able to create this cool ball roll and etc. etc. And those transforms on sides will basically let us to do the side kind of tip and twists. So let's zero out our rig pose, okay? And there's one last cleanup thing which I like to do. So currently our IK controls here have the same orientation as our joints which they're driving. Here they are the same. So the IK, because you remember we copied it. There could be a situation where, you know, somebody who was doing those controls, or maybe you have a little bit different controls, that could be not the case. What I like to do, just for the sake, I like to create a constraint. So I take that L-toe joint, transform. I just take maybe the other way. I take that transform. I parent constrain it to my IK driver, so to the ball IK. So it's kind of always here, but the orientation is exactly as an L-toe joint. So I have a transform which is exactly oriented as L-toe GNT, but it's driven by L-ball IK. And I use this one as a goal for our IK, and we're gonna do it this way, okay? So we always sure that that end joint is basically, so the goal has exact transformation as this one, which will be driving. So we take the transform which we're getting from our end, we create the node parent constraint. Here you go. And we're creating a stash node. So the stash input, it's just saving the transformation. So I wanted to come from the first input for the point number and the transform for that joint. So what it's gonna do, it's gonna stash that, it's gonna save that transformation, that matrix. The reason why we do that, because we don't want that to be moving. We just want it to be initialized. I want this transform as it is in default position, okay? And so we have that transform, which is not moving with the leg. It just stays what it is. And now I will transform, because otherwise you're gonna get double transformation. Now this transform, I will drive by my IK. And you collected your IK to the new parent and the stash to the X form. So the X form is that one which you're gonna drive. We select the parent constraint, we update the offsets, because there could be some offsets. In this case, there isn't any, but you need to update it. And we output X form will go to the goal. And that's basically it. That's your like double bone setup for the IK. Now what we need to do, we can of course test it and see if it works. Hit the enter and yeah, it working, perfect. Nice, so we have this nice part working here. Now let's just enclose it into HDA. So let's call it solve IK. Why not? And just do shift C to the subnetwork. Create digital asset. Let's just call it tutorial underscore error mode 2 joint underscore IK 0. And let's just save it. HDA like tutorial. And yeah, that will be okay. And accept. Cool. And we'll go to parameters. We'll jump here. Shift L to organize the network. Output, here you go, dive in, and let's see what we need. First of all, we obviously need the joint's name, right? And where they're coming from. So let's do folders. I will speed up the video so you can, recreate it on your own. Okay, so we have 3 folders, and now we take our root joint and we bring in our file and the joint name there. Let's just change it to root name. Apply. The end will be end joint, and the joint name will go here. We call it end name, and he will be, this one will be going here. Control name. Okay. Cool. Also, we need to have some settings. We can just be sure that the lookup asks are ported as well. Here you go. Good. Let's see if we have these ones. Perfect. If we go to menu, that will be our first one here. Change the script from H script to the Python. And here we're gonna copy this code and we'll change to Python, apply. Cool. And the vector, the offset for the transform, that's actually, we can expose it as well. So just grab that translate and we will put it here and we'll call it twist vector offset. Cool. And what else? Oh, we need the stash buttons, right? So the stash transformation, right? And we need also the parent constraint. We need the update the offset and clear offset, and we hit apply, accept. Cool. So sometimes people don't know how to check if their buttons are connected. If you right click on it, go to expressions and edit expression, you can see there's already connection, and the same way you can basically edit it here. And let's see our stash, right click, edit expression. Yep, it's basically connected. So we go up, we type properties, and we will change the folders to simple, as I always like to have. Accept, save, node type, and match the current definition. And let me just show you all that node. So yeah, we have a really cool, powerful node. Now we're just gonna go and apply for our toe, basically.